All right, in this part, we're going to solve a few of these quadratics. Notice I combined a bunch of examples into one because they were super related in my mind, so I'd rather just do them all together. So maybe I'll do a couple, and then you could pause it and try one on your own. So first, we are going to, let's see, we're being asked to solve each quadratic, so we're using the quadratic formula here. They want us to use the discriminant to determine the number of solutions and their type. Okay, so the type would be imaginary or real. Okay, so let's start by putting our quadratic in standard form. So I would subtract 5 from each side. Right, and that gives me my A, B, and C values that I'll use for my quadratic formula. The discriminant is b squared minus 4ac, so that will be 9 minus 4 times 1 times negative 5, which will be 29. Okay, so I found my discriminant, it's 29. And if you remember from up here, if I have a positive discriminant, then that means I'll have 2 real solutions. And I could check this. I could just graph this standard form equation, and I would see 2 x-intercepts. So because the discriminant is positive, I know that I will have 2 real solutions. So that's answering this part. Determine the number of solutions and their type. Now we're actually going to find out what the solutions are. So the nice thing about doing the discriminant as a separate step is when you go to use the full quadratic formula, which is, I guess it's up here, x equals the opposite of b plus or minus the square root of b squared. This whole part under here, we have already turned it into one number. It's 29. So I'll do x equals the opposite of b plus or minus the square root of 29 all over 2 times a. Those are my exact solutions. 29 is a prime number. I can't break that down. So this would be my exact solutions. One way I could check is I could find my decimal approximations here. Since these are real solutions, if I graph this, my standard form equation here, I would see that the x-intercepts are very similar to these, to my decimals that I would get here. So it'd be a good way to check it is to graph it. We can check real solutions by graphing, but we won't be able to do that with imaginaries. Okay, let's try another one. Okay, so let's go standard form. So I'm going to subtract the 12x and add the 4. Basically, I just need to get everything over to one side. Okay, so now that it equals 0, I've got my A and my B and my C. So my discriminant is going to be b squared minus 4ac. That's the formula for the discriminant. So this will be negative 20 squared. The parentheses there is important. Otherwise, you'll end up with you won't get the correct value, which should be a positive 400. Negative 20 squared minus 4 times A times C. And this becomes, if I check my calculator, 400 minus 400, which equals 0. So when my discriminant is 0, that means I will have 1 real solution. And I could confirm that. If I graphed it, it would my parabola would come down and the vertex would touch my x-axis and then it would bounce back up. So now if I want to solve this, I'll have x equals the opposite of b plus or minus the square root of the discriminant all over 2 times a. So this is just 20 over 50, which is 2/5. That is my only solution. There is no plus or minus because what we're adding and subtracting is 0. Adding 0 and subtracting 0 doesn't change anything, so we end up with just one solution. So why don't you, now would be probably a good time to pause this and try this on your own. See if you can work ahead, and then push play, watch a step, and try to correct your work as you go. So I would try this one on your own and see how it works out. Okay, I'm going to go ahead and get my standard form equation here. Okay, there's my standard form equation. Now I'm finding my discriminant. This is going to be 16 and, let's see here, 2652. It's going to be negative 36. So since my discriminant is negative, I will definitely have two imaginary solutions. So let's go ahead and plug it in. X equals the opposite of b, so it'll be negative 4, plus or minus the square root of negative 36 all over 2a. So there's my quadratic formula. The negative becomes an I, square root of 36 is 6. And then if I divide both of these by 2, the 4 and the 6, I would have 2 plus or minus 3i. Those are my two imaginary solutions. Nice. So here's a practice set you can work on your own or in your table groups. There are solutions over here that should match. So why don't you try a few of these. When you feel comfortable, move on to the next video.